Hello everyone, welcome to the Gate Engineering online learning classes. In this video, we will talk about the stable and unstable system, invertible and non-invertible system. So we'll check the system stability and invertibility. We'll check the given system is stable or not, or invertible or non-invertible. So first we start from the stability of the system. A system is said to be stable if the bounded input, bounded output stability criteria is satisfied. It means if the given input signal is bounded and we are getting bounded output signal in the output side or the receiving side, then we can say that the system is stable. Or in other terms, if the bounded input signal is producing some bounded output signal from the given system, that system is called as the stable. Now come to the what is bounded. What is the bounded input? So bounded input means if any signal which has finite amplitude throughout the time index axis. Let's see. This is the decaying exponential signal. It is bounded because near t tends to infinite, function xt or signal xt will become 0. So this is the bounded. That means amplitude should be finite throughout the time axis. And its expression representation is e to power minus 80. This kind of a signal is called as the bounded input or bounded signal. If you have a signal like this, rising exponential, which is e to power 80, if we substitute t equal to infinite, if we substitute t tends to infinite, we will get xt is equal to infinite. We will get xt equal to infinite. So this kind of a system is the this kind of a signal is the unbounded. Here we will get infinite. So this kind of a system is the unbounded. So it means if the signal has some finite amplitude throughout a time axis, that signal is called bounded signal. If we have bounded input signal and bounded output signal is generated from the given system, the system will become stable. In other terms, if we see ramp signal, this is the RT. So t tends to infinite, it will become infinite. So this is also unbounded signal. Now, this thing definition is the signal should have finite amplitude for bounded signal that we have already explained. I have already explained in the figure presentation. A BIB or stable system will have a bounded output for any bounded input signal so that its output does not grow unreasonably large. It should not grow unreasonably large. Like that for t tends to infinite, its amplitude should be finite or tends to 0. So that kind of a signal or signal is the bounded signal, and it bounded signal is producing some bounded output signal that we can say that the bounded system. Now, if we come to the invertible and non-invertible system, a system is said to be invertible if the input signal can always be uniquely recovered from the output signal. It means whatever we have in the output from by which we can uniquely we are able to uniquely recover the input signal or not from the given output signal. That kind of a system is called as the invertible. If we are getting more than one value for the from the output, so we can say that the system is non-invertible. So it should be one to one mapping between input and output for the invertible system. And in other terms, for the distinct input leads to distinct outputs. That means for a single input value, we should get the single output. But like that, if we take the square, x square t, if we take the x square is not an invertible because if we take the 2, if we take the square of the 2, we'll get 4. Same with times, if we give minus 2, we'll get 4 again. So for 2 value, we are getting the same output for same system, that is the square system. So that is the non-invertible because from 4 we can't recover 2 or minus 2 exactly uniquely because we will can get 2 as well as minus 2 if we take the square root of 4. From the xn, we are getting the yn. If we pass the yn to the inverse system, we'll get wn. This is for discrete time system and this is for continuous time system. If we multiply both of them, t and t inverse t, This will become identity system, because if we multiply both of them, we'll get one output one. That's why it is called an identity system. Now this is for the discrete time signal. This is the identity system for the discrete time system. Tn and T inverse n. Multiplication of Tn and T inverse n will become 1. Now we will check the systems are invertible or non-invertible. So here we know the property system xt input is given to the system. We are getting the yt, which is a 2xt here. Now we will have to uniquely recover the signal input signal xt, and we can easily recover if we multiply 0.5 1 by 2 in the yt. We can easily recover the xt. So wt is a new system or the inverse system, that will be 0.5 yt, and 2 will cancel out from the 0.5 or 1 by 2, then we'll get the xt. This system is the invertible. Now we come to the second. Yt is x square t inverse system, which is the inverse system will be plus minus square root of yt. So here we are getting two kind of the values, two values. One will be plus square root of yt, second value is minus square root of yt. So we are not getting the unique output value or unique value. We are getting two outputs of the inverse system. Therefore, the system is non-invertible. We should get one output from the one inputs. So here we are getting the two outputs from the inverse system. Thank you for watching this video.